Hello, this is Dr. Moberly, and we're going to work through the inverse Laplace transform two ways. We're going to do it with completing this square, and we're going to do it with partial fraction expansion in the second example. So the first example, we see that the minus 2s plus 4 would be an example of a perfect square. So let's make it s minus, minus 2. I goofed that up. Minus 2s plus 1 would be a perfect square. So we want s minus 1 squared minus 3, and then a plus 1. Let's see how that would work out. Plus 1. I think that's the right way to put it. So if we spread this out, it's going to be s squared minus 2s plus 1 minus 4, which is the same as s squared minus 2s minus 3. So we're looking at a equation that is 2 over s minus 1 squared minus 4. Looking back at the table, this appears to be the inverse Laplace transform of 1 over s squared minus a squared is going to be equal to the sinh of at. So we've got a equal to 2, and then this is going to be the inverse Laplace transform of this guy is going to be e to the 1t times sinh 2t minus by the S-shifting theorem. Oh, kind of already got that. The inverse Laplace transform that most closely matches is this. Oh, okay. And I have 2 over s squared minus a squared. I forgot the 2. We know that this inverse Laplace transform of this is going to be sinh at. Therefore, the inverse Laplace transform of this is going to be 2 times the inverse Laplace transform of that. And this property is called scalar multiplication. And I believe you were asked to identify scalar multiplication as a property of linear oh boy, can you spell linearity? And what is the other property? The other property is called superposition, which is that L of f of t plus g of t equals L of f of t plus L of g of t, which is equal to f of s plus g of s. Alright, let's do the other one. The other one looks like we need to do the quadratic formula minus 0 plus or minus square root of 0 minus 4 times 1 times negative 2 all over 2, so we've got square root of 8 plus or minus square root of 8 over 2, which is equal to 2 square root of 2 over 2, which is equal to square root of 2, plus or minus. So we've got 6 square root of 2 over s squared minus 2 is equal to 6 square root of 2 over s minus square root of 2 s plus square root of 2, and those are two linear factors, so it's going to be a over, actually I'm supposed to do all this on the next page, 6 over square root of 2 s minus square root of 2 s plus square root of 2 is equal to a over s minus square root of 2 plus b over s plus square root of 2. Multiply it out. We've got 6 square root of 2 is equal to a times s plus square root of 2 plus b times s minus square root of 2. And we know from this that a0 equals as plus bs, and 6 square root of 2 equals a square root of 2 minus b square root of 2, and so a and b are 3. So we're looking at the inverse Laplace transform of 3 over s minus square root of 2 plus the inverse Laplace transform of 3 over s plus square root of 2, which is equal to 3 inverse Laplace transform 1 over s minus square root of 2 plus 3 inverse Laplace transform 1 over s plus square root of 2, which is e to the square root of 2t plus 3 e to the minus square root of 2t. I think that's it. Done.